In this video, we'll look at how to solve exponential equations. So we'll look at 3 different ways to do that. Some of these ways might be familiar to you already, and if that's the case, then that's great. So we'll start with these 3 ways, and then in a different video, we'll look at some other options as well. So first of all, when we solve an exponential equation, that means to find the value of the variable that makes the left side and the right side of the equation equal. So in this first example here, where we have 3 to the x is equal to 9, really what we're trying to do is we're trying to find the value of x. So what value can we substitute into here to get a 9 on the left side so that it's equal to the right side? And we call this by inspection because you just do it by looking at it. And the idea here is hopefully there are some powers that you know, and if not, we'll talk about some other strategies. So for example, I know that 3 squared is 9. And in this case, we have that the left side and the right side are equal. They both have powers with a base of 3. The only thing that's different are the exponents. So if the left side and the right side are going to be equal, then x has to be 2. All right, and the next method is what we call systematic trials. Basically, it's a method of trial and error, to guess and check, to try to kind of make things work. So the idea here is I know that if I want to find 3 to the x, what value of x here is going to make the left side equal to 20? I know that 3 squared is too small. 3 squared is equal to 9. That's definitely too small. We're going to jump all the way down here because I also know that 3 cubed is 27. If you don't know that, you can certainly use a calculator. And that number's too big, so I need to go somewhere in the middle. So I'm going to start halfway in the middle. I know that the answer is probably closer to 3 than it is to 2 because 27 is closer to 20 than 9 is. But I'm going to go smack dab in the middle just to see. So 3 to the 2.5. If we type that into our calculator, we'll get approximately 15.6. Remember, our goal is to get 20, right? Our goal is to get 3 to the x is equal to 20. Whatever that x value is, that'll be our answer. So 2.5 isn't quite big enough. So I'm going to jump ahead here to 2.7. So 3 to the 2.7 gives us 19.4. Again, not quite big enough. It's close, but not quite. Let's try 3 to the 2.8. 3 to the 2.8 gives us 21.6. That's too big. So 2.7 was too small. 2.8 is too big. So I'm going to choose a number in between 2.7 and 2.8. So I'm going to go halfway in between. So 2.7, whoops, that's a 7. Let's try that again. 2.75. So 2.75 is halfway between 2.7 and 2.8. And 3 to the 2.75 gives us 20.5. So we do have a 20 here. Most often we would probably round 20.5 to 21 rather than 20. So maybe let's try to go a little bit more precise. So 2.75 is too big. We're a little bit bigger than 20, so I'm going to try something a little bit smaller. We know for sure we need to be somewhere in this range here between 2.7 and 2.8. But 2.75 is too big. So whoops. That eraser was a bit big. Let's backtrack a little bit. So that was a 3.275. Let's try 3 to the 2.7. I don't know. Let's go 2.73. I was trying to decide between 2 and 3 there, sort of the halfway point. And 3 to the 2.73 gives us 20.07. So to 1 decimal place, we have the correct answer here. And again, the accuracy may be sort of dictated in the question. I think this is close enough for what we're looking for. So the x value that makes this true is 2.73. So 2.3 to the 2.73 will give us approximately 20. So we can say that our answer is approximately equal to 2.73. All right, let's look at one last way right now for how we can solve an exponential equation. And that way is using a graph or by graphing. So here's an equation, 2 to the x is equal to 5. We know that 2 squared is 4. We know that 2 cubed, 2 times 2 times 2 is 8. 4 is too small, 8 is too big. We could use that systematic trial and error that we just talked about, or we could use a method of graphing. So here is the function of, this is the function y equals 2 to the x. And we want to see, where does this function equal 5? Well, 5 is up here. So really, we want to see, what is this value right over here? And in order to do that, what we can do is, in Desmos, we can graph the function 2 to the x. And then we can just graph the line y equals 5. And when we do that, we get something that looks like this. If we then hover our mouse over the intersection point, click, and then just kind of hover over that point, you'll get this little box here that tells you what the x value is to give us an answer of 5. So this just tells us that 2 to the 2.322 is equal to 5. So in this case, the answer would be that x is equal to 2.322. And again, you can use your calculator to check. Does 2 to the 2.322 equal 5? I'll put a little question mark, say, does this equal? And once you run that into your calculator, you should see that you get maybe not exactly 5, but it should be pretty darn close to 5. Same idea over here. 4 to the x is equal to 64. That we can start by graphing the function y equals 4 to the x just by typing it in. That's the red one here. And then we just graph the line y equals 64. So here's the line y equals 64. We want to find their point of intersection. And in this case, we can see that x is equal to 3. So the solution here, x equals 3. Again, you could plug in 3 to the equation and see. So I want to show you how to do this in Desmos just so you can see it. So our equation now is 1.05 to the x equals 1,276. So a little bit harder of an equation to do, but we'll go through the process in Desmos. If you can do a hard one in Desmos, you should be able to do the easy ones. All right, so I'm going to start by typing in the equation. So y equals 1.05 to the exponent x equals 1,276. Sorry, we don't need that equals. That's going to be a separate line. Sorry, there's my function y equals 1.05 to the x. It looks more like a straight line, and that's just because of the way that we're zoomed in. And the second thing I want to enter is the equation, the right-hand side of the equation. So I want to know when the y value is equal to 1,276, because our equation was 1.05x equals 1.05 to the exponent x equals 1,276. And you can see here, I can't see it. My scale doesn't go up that high. So I can just click on the wrench over here in the top right-hand corner. You can't really see that very well or at all. But if you click on the wrench in the upper right-hand corner, there we go. Maybe that's better. In the top right-hand corner, you click on that wrench, you'll get this pop-out menu. And I want my y value to go, let's say, to about 1,300. That'll be enough to be able to see everything. So there's the y value of 1,300. You can see the green curve that we graphed is way at the bottom. The line is way at the top. That means our x value isn't big enough. So we do a couple things. We can zoom out a whole bunch. And you can see, or I just grabbed the screen with my left mouse click and just dragged and panned things around. I can now see where that point of intersection is. I can zoom in a little bit if I want to make it a little bit bigger. Click my mouse on the point of intersection and just hover my mouse over that location. And I can see that the x value is 146.576, and the y value is that 1,276 that we were after. So that 146.576 is the answer to our equation. So if we just flip back to the question here, we get an x value. So x is equal to 146.576. And again, depending on what type of accuracy you're looking for, maybe you don't need to go to 3 decimal places, but it was given to us, so we just used it. So 3 ways to solve exponential equations: one by just inspection, looking at it, knowing what the answer is; one by systematic trials; and one by graphing. In a different video, we'll look at one more method to solve exponential equations.